Okay, it's time to tackle 10-2. Make sure you have something to write with, of course, and a piece of paper to write your notes on, or even better, that you have printed the document that's on the lesson. I know not everybody has an access to a printer, and that's no problem because you can easily draw the figures. All right, let's get started. So for 10-2, we're dealing with lines that are tangent to a circle. So what does that mean? What is a tangent to a circle? Well, it is simply a line that intersects, I like to think of that as touches, the circle in exactly one point. And that particular point is called the point of tangency. So if we look at this picture, I have a circle, and this line here only touches the circle in one place. So this is a tangent line, and point X is the point of tangency. Now if you look at CX, that's a radius, and if you look at CZ, that's a radius. And of course all radii are the same. So if I were to take this radius and add on a piece, then that will always be bigger than a radius. Okay, so that's what this says. CX, the radius, is always smaller than that radius plus a point outside. In other words, a point on the line of tangent. Okay, now theorem 10-2. Theorem 10-2 tells us that if you have a tangent to a circle, then that line is going to be perpendicular to the radius. In other words, here we go. We have a tangent to the circle. So I now know that that tangent line, AB, is going to be perpendicular to this radius, CP, that segment. Okay. The shortest distance between a point and a line is the straight, is the 90-degree or the perpendicular piece. So this distance is always going to be smaller than adding on any little piece. So therefore, these will always be perpendicular. Now, the converse is true. If you start off with a statement that you have perpendicular, then you can automatically show that the line is tangent. All right, so let's tackle an example. Try to figure out if KJ is tangent to circle P, and it sure looks like it. Well, if this is a tangent, then this radius is perpendicular, making a 90-degree angle. And if this is a 90-degree angle, then this is the hypotenuse. The hypotenuse is 10. Think about now, how can I check to verify that that's a right angle? Hopefully you're thinking Pythagorean theorem. A squared plus B squared equals C squared. Well, and I know 10 times 10 is 100. And then 81 plus 36 is 117. It is not a tangent. Sure looks like it, but you can't go by looks. Looks can be deceiving. Okay. Now on example 2, they are giving you that ST is a tangent. That should say what is the radius of circle R? Well, the radius is X in both cases. Now, since this is tangent, Pythagorean theorem holds. X squared plus 24 squared equals the hypotenuse squared. All right, well this side's pretty easy. X squared plus 24 multiplied by itself is 576. Do you remember how to do that now? That's an Algebra 1. Memory lane. FOIL. X plus 18 multiplied by itself. X squared is your first. Your outer's 18x and your inner's 18x. That makes 36x. And then your last 18 times 18, 324. Now my whole goal is to get x. What do? Hopefully you said solve it. If you subtract x squared on both sides, it'll be gone. And then if I subtract the 324, I have 252 for 36x. And of course, divide by 36. And I have an answer of 7. The radius of that circle is 7. Now, if the algebra confused you, go back and replay this and see if it can come back to you. All right, moving on. In example 3, we have line M right here, tangent to the circle at B, and N tangent to the circle at C. And we're wanting to figure out the value of x, this angle. Well, you're given this one is 135. Notice this is a four-sided figure or a quadrilateral. How many degrees is a quadrilateral? Hopefully you said 360. I've used up 135, and since these are tangents, these are each 90. Perform the subtraction. Okay, and x should equal 45 degrees. All right, example 4. We're trying to figure out if MP is tangent to the circle. Well, if this is a tangent, then this has to make a 90-degree angle. How many degrees in a triangle? Let's see if it works out. That has a sum of 181. So is it tangent? No. This 90 didn't work. It was a little bit too much. Now, for part B, we do know that LK is tangent. So we do know that this is a 90-degree angle. We're looking for K. I wrote KM. That's a typo. I'm sorry. It should say KN. That's the hypotenuse. A squared plus B squared equals C squared. How much is this? Well, here's a hint. It's a radius. All radii are the same. Okay. A squared plus B squared equals C squared. Okay. 9 squared is 81. Go ahead and pause the video while you FOIL x plus 5 and you FOIL x plus 8. Did you get it right? All right, now go ahead and subtract the x squared from both sides. I'm going to go ahead and subtract the 10x. I have 81 plus 25, which is 106, equals 6x plus 64. Subtract the 64, and I have 6x equals 42. Oh, that was coincidence. X equals 7. Okay, so since x is 7, now I'm ready to answer the question. The question wants to know what Kn is. Well, Kn is x minus 1 and the 9. So Kn is 15. Be careful that you didn't stop with the 7. I actually did that initially and I had to go back and edit the video. All right, Theorem 10.2. If two segments with a common endpoint exterior to a circle, in other words, these two segments have an end that's outside of the circle, and they are each tangent to the circle, so this is a tangent and this is a tangent, then those segments are going to be congruent. They're going to have the same measurement. AB equals AC in this case. Now, you can actually go through the proof of this, and it is in your book on page 447. They'll end up drawing a line here so that you have two triangles. And then they're going to show that these triangles, using hypotenuse leg, are congruent. And then by CPCTC, all the parts are congruent. Therefore, these are going to be congruent. Now that's neat because it makes a problem like number 5 very easy. You're wanting to find the perimeter of this weird four-sided shape. Well, you know that if you have a tangent, the pieces are the same. So these are the same, these are the same, and so are these. So this side is 13, this one is 9, this one is 5, and this one is also 9. Remember, perimeter, you add up all the sides. And what, 8, that'd be 36. All right, I think you're ready to do the homework now. Go back and re-listen to any of this that you need to.